This test is for Deepseek Coder V2 16 billion model to provide a list of 53 words, starting with letters WH, in a numbered list sorted alphabetically. There are to be no duplicate words in the list. Its bigger sibling boasts parameter size as a 238 billion model. Nevertheless, 16 billion parameters should be plenty enough for this task. As we can see, straight out the gate, the model stated it was unable to create the list of 53 unique words starting with W and H due to its limitation on word generation in its database. Oh, really? The model went to explain that, instead, how I might approach such a task if it were even possible. Really now. And proceeded to suggest that I could brainstorm words that begin with W and H. Then I could check for uniqueness as the list is being compiled. Then the model proceeded to push out the list. Needless to say, looking at the list, we see the list off in alphabetical order using W, H, and I, then W, H, and E. But then, at line 8, inserted W, H, and A letters, then again to W, H, and then back again to I, E, H, and E. We see this pattern throughout the list, out of sequence in terms of alphabetically. The model finished the list with the word Whitneyite, letters being W, H, and I. Then went on to conclude that the list is not comprehensive and did not include the 53 unique words, but to demonstrate how I might go about in compiling such a list. Oh, really? Deepseek Coder V2 16 billion model, really? I took the opportunity to explain to the model that its idea of not possible to produce such a list is misconstrued. A model tested has indeed completed the challenge. Furthermore, I wanted to explore why the model gave the impression of a non-runner so early in the challenge. I asked the model to try again. The model apologized and proceeded. This second list was no better than the first. We see at position 5 the word wither and alphabetically, or mixed up. The model concluded on the 53rd word as whartonized, letters being W, H, and A. It went on to state that the list is not exhaustive, with duplicates or missing words. Further, the model went to highlight that if I need a more accurate or extensive list, I should provide additional details or specify any particular criteria for inclusion. Okay. As far as I am concerned, the task has been clear from the outset. Provide a list of 53 words, starting with WH, in a numbered list sorted alphabetically, and that there should be no duplicate words in that list. That is the requirement. Again, the model apologized and this time stated it will create a unique and accurate list of 53 words starting with W and H. The updated list was still out of whack. I am under the impression that the model was making up words to get to the 53. Well, that is interesting because it mentioned at the outset in no uncertain terms that words will be presented according to what is retrieved from its dataset for which it has been trained. So has the model been trained on words that do not exist in any known dictionary? I wanted to amuse myself and pluck out one of the words randomly. For instance, I looked up the word at line 40, whippetry, but could not find anything on it. How about word at position 50, wealth-like? Nothing. Please do let me know in the comments box if all these words do have meaning. Some of them I see are related to animals. Needless to say, the list is far from being in alphabetical order as the requirement asked for. I decided to query the model's ability to converse as a recognized coder. Was quick to come back and respond with algorithms and data structures. Okay. Probed further about dialogue and client requests. communication is just as important as an ability to code, so as to understand client requests. It's stated that effective communication is key to understanding and fulfilling clients' needs accurately. Being able to ask questions, clarify requirements, and provide solutions that meet or exceed expectations requires not only technical skills, but also strong interpersonal and analytical abilities. It goes on to say that as a programmer, it is important to be open to feedback and willing to adjust the approach based on the client's responses. This back-and-forth dialogue helps ensure that both parties are aligned with the project goals and that deliverables align closely with what the client envisions. It also allows for better management of expectations and potential issues, ensuing a more successful outcome. Well, this is exactly the response I expected from Deepseek Coder version 2, 16 billion model. The bottom line is that most programming languages in the world are made up with characters, letters, and words which forms the language syntax. This challenge is therefore relevant for the large language model. the Deepseek Coder V2 16 billion model to try again with the original requirements, but unfortunately this time only ended up with 18 words in the list. Okay. I wonder if it thought I was whining, seeing how that is the last word in the chosen list. Even though the model stated it is creating a list of 53 words, the total count here is clearly 18 and not even in alphabetical order, so I asked if it had finished. The model apologized and attempted to finalize and present a complete list, but did not finish the sentence. I can confirm on my side that I have not run out of memory, honestly. So I asked the model what has happened here. The model proceeded again to present the list, but 53 words this time around. Unfortunately, not in alphabetical order. Looked up line number 30, whirlwind, for example, and that does not exist in any known dictionary. It was suggested that the model will require further deep learning algorithmic training, as the expectations was not met on all accounts. This was even after the request was reiterated. No doubt, Deepseek Coder version 2, 16 billion model, will continue its training of datasets from diverse sources. Definitely, fine-tuning on specific tasks such as tokenization, i.e., breaking down data into manageable words, will be needed.